And first, a couple general announcements. Today we're going to start looking at parabolas. Probably take us 2 days to go through parabolas. Again, these homework assignments, when I set them up in August, I had thought that some of the material would take longer to get through than it has. And so they're kind of down a ways. Please don't wait to get started on those assignments. Homework 2.8 is what we had worked on Friday. 3.1 is what we'll be working on today and next Friday. So that test 3 will be due by the end of the day on the 23rd. Reminder that Wednesday, the 11th, is the holiday Veterans Day, and so there are no classes. There is a linear quiz that's in my math lab that will be due before midnight on Thursday the 12th, because we don't have class on Wednesday. I pushed it back a little bit. The quiz is in my labs. You must submit your work in Blackboard. The grade in Blackboard is the one that counts, not the grade in my labs. And so if all I have is a list of answers, you are not going to get full credit. Also, in my lab's grade book, I had weighted it so that the only thing that counted in that grade book is your homework grade, because that's the only grade I'm taking right out of my labs. Again, for the tests and quizzes, I want to see your work, and I want to be able to give you partial credit for your work. So those are the Blackboard grade that counts. However, over the weekend, somebody pointed out to me that they cannot see their tests and quizzes in my labs after they take them. And I realized that it was because that doesn't count as part of your grade, so they don't show up in your grade book. So I don't remember if I did it for your class or just my contemporary math classes, but hopefully before I see you again on Friday, they will show up. I'm going to weight them, but they'll only be 1% of your grade, so it won't really have an effect on much of an effect on your my lab's average, but by doing that you will be able to see those papers in my labs. In the Blackboard grade book, you should always, if you submitted pictures to me, be able to click on them and see them. So any questions on any of that?
I was going to ask a question on the homework.
I was going to just say that the next that I want to go is that I had gotten a question on the homework over the weekend. And so I wanted to look at that and then see if there were any other questions on the homework. So are we looking at assignment 2.8 question number 2?
Yeah, 1 or 2, but
Okay.
I think I might have been daydreaming when you did that, because I tried solving it. I was like, man, I don't know.
Well, let's look at number 2, because I had gotten an email over the weekend from somebody with concerns about that one, because most of the examples that we had done in class involved whole numbers, and question number 2 definitely doesn't. And so question number 2, what we're being asked for is the distance between 2 points, and the points are 2.3 comma 9.2 and negative 0.7 comma 6.2. So those are definitely not whole numbers. But whenever I look for the distance, I use that distance formula. The distance between 2 points is the square root of the difference in the x values squared plus the difference in the y values squared. And so whether those numbers are whole numbers, integers, decimals, or fractions, I'm going to subtract the x values. So let me take 2.3 minus the other x value is negative 0.7, square it, plus the difference in the y values would be 9.2, minus the other y value is 6.2, and I need to square that. I apologize, I didn't draw my radical line. Order of operations, we're going to do what's in the parentheses first. And so 2.3 minus negative 0.7, that double negative becomes a positive. So that becomes 3 squared. Plus, and now when I do this subtraction, I also get 3 squared. Now, square, and that gives me the square root of 9.9, which gives me the square root of 18. Shouldn't be surprised because it says we should use radicals if they're needed. So either we're going to get an exact answer or an integer or a radical. It says to simplify. So when I look at the square root of 18, does everybody see 18 is 9 times 2? And so the square root of 9 is 3. And so my final answer is 3 radical 2. Is that okay? Can I put a smiley face next to it?
Yeah, that's good. Thank you.
Okay. Does anybody else want to look at any other questions from any of the other homework assignments for this unit or for anything from before?
2 and 2.4.
Sure. Oops, I got to turn my cursor back into mouse. 2.4. Question number 2.
Yep.
And while we're waiting for that to come in, Ryan, I just got that you came in. So question number 2. Says write an equation for line L in point slope form. It's perpendicular to y equals 4x. So a couple of things going on here. If it's perpendicular, to y equals 4x, well, this line has a slope of 4. So the slope of my perpendicular line, to be perpendicular, it's a negative reciprocal, so it's negative 1/4. So we've got a slope. The other thing that we need is a point. And we're given on the graph that it goes to the point -1, -4. And so they want it in point slope form. Point slope form is y minus the y value of the point is equal to the slope times x minus the x value of the point. So that gives me y minus -4 would be y plus 4 is equal to -1/4 times x minus the x value would be x plus 1. So far, so good.
Yeah, thank you.
Does this, it asks this in other part. So I'm guessing in the other part, they ask for it in slope intersect form, in which case then you distribute y plus 4 equals -1/4 x minus 1/4. And then subtracting 4 from both sides, we get something crazy like y is equal to -1/4 x minus 17/4. Okay,
Okay, thank you.
you're welcome. Any others? If not, I'm gonna clear this, get out of my labs, and start by picking up from where we left off. And if it makes you guys feel any better, the other section got equally badly treated today as you guys were last class. The computer, even though it's plugged into the walls, the battery was dead, and so we ended up having to mess around with things. Hopefully it won't happen again today. But last class we were looking at circles, and we had said that our favorite form of the equation of a circle is that center radius is form x minus h quantity squared plus y minus k quantity squared is equal to r squared, where hk is the center and r is the radius. And if our equation is in that form, life is good. You can pick up the center and the radius by inspection. However, we came up with problematic questions where it wasn't in that form. Things like if I wanted to find the center and radius of an equation, x squared plus y squared plus 16x minus 12y plus 19 equals 0. And we had said, looking at this, that we know it's a circle because both x and y are being squared and they have the same coefficient, which in this class should be 1. Once you get older and wiser in math 111, then you'll find that those coefficients might not necessarily be 1, but they will be the same. And so we needed to take that equation and put it in that center radius form in order to answer the question that's asked. And so I'm going to rewrite it, x squared plus y squared plus 16x minus 12y plus 19 equals 0. And now I'm going to ask for a little bit of help. Can anybody remind me of what we did first in order to try to put that equation in that center radius form?
We moved the constant to the other side and then grouped the x's and y's together.
Beautiful. And so we'll subtract the 19 from both sides and commute here, rearranging so that we get x squared plus 16x. Then I'm going to leave a little bit of space, plus y squared minus 12y. Leave a little bit of a space, and that equals negative, oops, it would help if I wrote the right number. Sorry, folks, negative 19. Now that it looks like that, can anybody remember what we did to fill in these spaces?
Completed the square.
And how do you do that?
So for 16, you divide that by 2 and then square it, and then you do the same to 12 and add that answer to negative 19.
Beautiful. So 16 divided by 2 is 8, squared is 64. So I'm going to add 64 to fill in that spot, but what I do to one side, I have to do to the other. Same way, negative 12 divided by 2 is 6, squared is positive 36. So I add 36 there. So that gives me x squared plus 16x plus 64 plus y squared minus 12y plus 36. And the arithmetic on the other side, if I'm not mistaken, gives me 81. Then what did we do with that trinomial?
That would be x plus 8 squared and then y minus 6 squared equals 81.
Beautiful. We factor them, but because of the choice of constants that we added, we knew we had a perfect square trinomial, so we get a binomial square. And now we can look at that and compare. And we can see that the center is, remember, if this is addition, it means we were subtracting a negative number. The x value of the center is negative 8. If it's subtraction, that coordinate would be positive. And the radius is the square root of the constant on the other side, so the radius would be 9. How are you folks feeling about that work? Are we comfortable? Are we on top of our game? Or would you like to try one more? Not hearing anything? I'm going to ask you folks to do one more on your own. I want you to find the center and radius of, and the equation we're starting with is going to be x squared plus y squared minus 4x plus 2y minus 85 equals 0. And I'm going to be quiet for a couple minutes and ask you folks to just tell me what the center is and what the radius is. And while you're looking, I have to apologize. I know I just let someone else in the room besides Ryan. I'm trying to remember whom it was. I'm having a brain freeze. I think I got it. How are you doing? Hello?
Hey, computer die again?
Yeah, it did. And it's plugged in and it says it's charging, but it says that I think it's saying that the battery is dead. Let's give it a minute. If it doesn't recharge, okay, it's starting up now. I just hope it doesn't do this for my night class. Okay. Okay, I think I got it back. I think it's still recording. I hope it's still recording. The recording might be in two different parts. But did anybody else get this to have a center of 2, -1, and a radius of 3, radical 10? Are we good or no? Can you guys hear me?
Yeah, I'm good.
Do we need to add details or are we all right? Okay, I'm going to add details because I'm not hearing anything. There would be x squared minus 4x plus y squared plus 2y. Adding 85 to both sides would make it equal 85. When I take that -2, divide it by 2 and square it, I add 4 to both sides. When I take that 2, divide it by 2 and square it, I add 1 to both sides, giving me x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 90, or x minus 2 quantity squared plus y plus 1 quantity squared equals 90, giving me a center of 2, -1, and the radius would be the square root of 90, which simplifies to 3, radical 10. We good? If so, next place we're going to go is we're going to start looking at the graph of a quadratic function. So it's a function, so we'll say it's f of x equals, and since it's quadratic on the other side, I'm going to have ax squared plus bx plus c. We're going to specify that a cannot be 0. If a is not 0, we'll always have that squared term, so we'll say it's a second degree equation. And b and c can be any real numbers. And so we're going to be considering the graph of an equation of the form y equals ax squared plus bx plus c. We're going to find that the general shape is called a parabola. And when we were looking at finding the domain and range of a function from its graph, we did have some that had that parabolic shape. We're going to see that there's a couple of ways of sketching one. And to sketch one, one method is to look at the transformations of a basic parabola, y equals x squared. So it's to look at all of them as a transformation, which is moving around in the plane of a basic parabola which would be my y equals x squared. And so I'd like to take a little bit of time to develop this idea. So let's consider the graph of f of x equals x squared or y equals x squared. In order to look at all of these graphs, I'm going to go back very basic and look at our table of values. And we're going to be putting several graphs on the same set of axes. So I'm going to draw relatively large axes. And for the first graph, y equals x squared, and for most of these, I'd like to look at values from the domain going from 2 to -2. And so substituting when x is 2, y is 2 squared, which would be 4. When x is 1, y would be 1 squared, or 1. When x is 0, y is 0 squared, or 0. When x is -1, y would be -1 squared, which turns out to be +1. Remember, when you're substituting in a negative value, those parentheses help you keep your signs straight. And when x is -2, when I square -2, I get +4. And so my points that I have are 2, 4, 1, 1, 0, 0, -1, 1, -2, -4, and I get this basic shape. as I look at it, does everybody see that it opens upward? If I could draw, it would be symmetric, meaning it should look like it's a mirror image. And the symmetry line, the axis of symmetry, would be the y-axis, which is my line x equals 0. And as I follow the graph, it's going down, and then it hits a point and changes and goes up. And that vertex, which is the point where it would change, is the point 0, 0. So that the vertex is like our turning point. So far, so good. Now, on the graph, I'm going to make this just a little bit smaller so we can fit a little bit more on one page. And I'm going to do the next graph in a different color because I want them to all be on the same axis. Oops, I forgot to label that one, right? That one was my basic y equals x squared. When you put several graphs on the same axis, you should label them. And so next, I'd like to consider y equals x squared plus 2. What happens if I add 2 after I square? For my table of values, I'm going to still use from 2 to -2 inclusive, but this time I'm substituting into y equals x squared plus 2. So when x is 2, y would be 2 squared plus 2. 4 plus 2 is 6. When x is 1, y would be 1 squared plus 2. 1 plus 2 is 3. When x is 0, y would be 0 squared plus 2, which would be 2. Again, be careful when you substitute those negatives in. -1 squared is 1, plus 2 is 3. And lastly, when I substitute in -2, -2 squared is 4, plus 2 is 6. And so this time I have 2, 6, 1, 3, 0, 1, -1, 3, and -2, 6. And as I look at that blue curve, y equals x squared plus 2, when I compare the blue curve to the black curve, does everybody see that they have the same basic shape? It's still a parabola. It still opens up. Its axis of symmetry is still that same y-axis, the line x equals 0. But what happened is my vertex or my turning point moved up. Oops, I apologize. I plotted that point wrong. That should have been 0, 2. I'm sorry. It's the point 0, 2. And do you notice that what I did was I just took that whole graph and shifted it up? So I'm going to add a page here and look at my general rules for transformations. And if I have a graph of y equals f of x, if I take y equals f of x and I add a value to it, I will always shift all of the points up whatever a is. Now going back to my graph, When I added 2, I moved each of the points up 2. Does it make sense that if instead of adding 2, I would have subtracted, it would have moved them down? And so we'll say that if I have y equals f of x minus a, we'll shift down a. Next, let's consider y equals, in parentheses, x plus 2 quantity squared. And let's see what happens if we add the 2 to the x value before we square it. What happens to our graph? Again, from x, I'd like to substitute the values from 2 to, I think this one, I'm going to go just a little bit past -2 to -3. I'm substituting into y equals x plus 2 quantity squared to find y. So when x is 2, here y would be 2 plus 2, or 4 squared, which is 16. When x is 1, y would be 1 plus 2, or 3 squared, which is 9. When x is 0, y would be 0 plus 2 squared, or 4. When x is -1, y would be -1 plus 2 squared, or 1 squared is 1. When x is -2, y would be -2 plus 2, or 0 squared, which is 0. And at -3, y would be -3 plus 2, or -1 squared, which is 1. And so if I go and try to plot those points on my same axis, at -3, it's 1. At -2, it's 0. At -1, it's 1. At 0, it's 4. At 1, it's 9. And past there, I'm kind of off my axes here. But if I look at this green graph, you see that it also has that same shape. It's that same parabola. It's going upwards. But this time, I moved my symmetry line so that my axis of symmetry is the line x equals -2. And my turning point on that axis, my vertex, is the point -2, 0. But as I look at that, when I moved that axis 2 to the left, you see I took every point on that black graph and moved it 2 to the left. And that came when I added 2 to x. So I'm going to say if I have y equals f of x plus a, if I add a value, I shift left a units. And instead, if I have f of x minus a, I shift right a units. This is a little counterintuitive because most people think of a as being positive, but adding that to a does shift it the other way to the left in a negative direction, and subtracting shifts it right. And this picture isn't messy enough. We want to consider one more. This time, let's consider y equals the negative of x squared and see what happens there. Let's keep our x values from 2 to -2. And we're going to take the negative I apologize, the exponent should be in the parentheses of x squared to find y. So if y equals the negative of 2 squared, that would be negative 4. If y equals the negative of 1 squared, that would be negative 1. If y equals the negative of 0 squared, it would be 0. If y equals the opposite of negative 1 squared, that would be negative 1. And if y equals the opposite of negative 2 squared, that would be negative 4. And so when I look at what happened to my original black graph, when I multiplied by a negative, at 2, it's negative 4. At 1, it's negative 1. At 0, it's 0. At negative 1, it's negative 1. And at negative 2, it's negative 4. And you see it's got that same basic shape, but I've kind of flipped it over the x-axis. And so this one opens downward. Its axis is still that line x equals 0, and its vertex is still that point 0, 0, but I kind of turned it upside down. I flipped it over. And so when we look at our general transformations, if I look at y equals the negative of f of x, I flip it or I reflect it over the x-axis. I want to just for a minute go back and look at the graph, but I think there's too much going on there to try to put another graph on there. But instead of adding or subtracting 2, you see that if I would have taken each of those y values and multiplied it by 2, I would have taken all of the points and moved them up. I would have stretched it. And so we'll say that if I have y equals a times f of x, it's going to be a stretch or an elongation if a is greater than 1, and it's going to be a shrink if a is between 0 and 1. To multiply by a half, it would be half as high. And so if I think of taking all of those and transforming my basic parabola, y equals x squared, and instead get y equals a times x minus h quantity squared plus k. This is considered vertex form. And we notice that if a is greater than 0 or positive, if a is positive, it opens upwards. Or I think of it as being, if a is positive, a happy parabola. If a is less than 0 or negative, it opens downward, or I picture it being a grumpy parabola. Now, if I'm subtracting h, it means I'm moving right h and up k, and so that would move my vertex from the general 0, 0 to the point hk. And so these constants give me my vertex, which is why this is called vertex form. And when we're looking at these as functions where they're solved for y and x is squared, the axis always goes through the turning point. So it will be the line x equals h. And so that information is going to be an awful lot for us to use when we start trying to sketch a parabola. We're going to just look at three additional points. We're also going to consider, for additional points, my intercepts. I totally misspelled consider there. I'm sorry, folks. This is what happens when I try to write, talk, and think at the same time. The intercepts. So for the y-intercept, we said we'd let x equal 0. And for the x-intercept, to find that, we said we'd substitute y equals 0. And so the way, if a circle is in center radius form, we could get everything that we needed to sketch it, to draw it, the center and the radius by looking at the equation. We're going to see that we can get most of what we need to draw a parabola if it's in this vertex form by looking at the equation. So, is everybody caught up? Do you need me to wait a minute before we look at an example? Or are we good?
Good.
Good. Okay, great. So for our first example, let's sketch f of x equals -2 times x plus 3 quantity squared plus 8. And I want to compare that to my y equals a times x minus h squared plus k. First thing I always look at is what direction this goes in. And the direction is determined by a, which here is -2. Because it's negative, it's going to be a grumpy parabola or open downward. Second thing that I want is my vertex. And we said our vertex is our point HK, where H is what I'm subtracting from X. Because it's addition in there, I'll say I'm subtracting a -2. But K is that constant that I'm adding. So my vertex is -3, 8. Then I'm going to consider my axis of symmetry, which is always that vertical line through the vertex. So it's always going to be x is equal to the x value of that turning point. So, very rough sketch. We know that our turning point is -2, 8. We know that from there, we will be opening downward. And so we have a general idea of what it's going to look like. In terms of adding more detail, points that are usually important to look at are our intercepts. And so first, my y-intercept, we plug in x equals 0. And so f of 0 is -2 times 0 plus 3 quantity squared plus 8. So let's see, that would be -2 times 9 plus 8 gives me -10. And remember, we have this axis of symmetry at -3. So I'll have a mirror image point on the other side of the axis. I'm going to fold over my axis. If this were on graph paper, it would be easier to sketch that accurately. Other points that I'd like to know are my x-intercepts, because they give us what's considered the zeros of the function. And so those occur where y equals 0, which gives me 0 is equal to -2 times x plus 3 quantity squared plus 8. Being that my equation is in this form, I think I'm going to try to solve this using the square root property. How? Let's subtract 8 from both sides, giving me -8 equals -2 times x plus 3 quantity squared. Dividing both sides by -2, I get 4 equals x plus 3 quantity squared. And so when I take the square root of either side, I get 2 equals x plus 3, or I get -2 equals x plus 3, giving me x equals -1, or x equals -5. So, going back to the graph, we cross the x-axis at -1 and -5. And so now we've got finding the intercepts, the turning point, and knowing the direction. We have 5 points on our curve. And we see that, yeah, it's stretched a little bit because we were multiplying by 2, but it's that parabola turned upside down.
So for this, will we always need at least 5 points?
What you're going to be looking at, you'll always be looking for the direction, the vertex, and the intercepts. How many intercepts really tells you how many points you're going to get. And we'll see that with our next example. But before we go further, there's a couple of things, and I apologize. I'm going to be bouncing up and down a little bit because I want to refer back to the graph. But a couple of other things that you might be asked is, does the graph have a maximum or a minimum? And so if I go back and look at my graph, that turning point downward, that turning point is a maximum. And so here we'll say that the maximum occurred at x equals -3, the maximum value is 8. And when whenever it opens downward, we'll have a maximum. And instead, if it opened upward, we'd have a minimum. Now, another thing that we might be asked, and I guess I'll try to put it in a little box here below the graph so I'm not moving around too terribly much, is what's the domain? Because this is everywhere defined, I've got those arrowheads that are sort of pointing left and right. For these parabolic functions, the domain will always be all real numbers or from negative to infinity. For the range, if I have a maximum, I have a high point, which is that 8, and I will not have a low point. Instead, does it make sense? Is if I had a minimum, instead my range would have a lowest value and not a highest value. So, what do you think in terms of sketching parabolas this way? Shall we try another one? Can I turn the page or do I need to wait a minute? Not hearing anything. Let's do one more today. Let's sketch f of x equals x plus 3 quantity squared plus 1. We need the direction and the axis. The direction we said is determined by A, which was the coefficient on the squared part. And so over here, what number is in the place of A?
1.
1. Is that 1 positive or negative?
Positive.
Positive. Since it's positive, we know that it's opening upwards. And since it's opening upwards, we'll have a minimum. Now, the turning point, the vertex, is HK.
Negative 3, 1.
Beautiful. Negative 3, 1. And so here, I know that my turning point is negative 3, 1. And from there, my parabola is opening upwards. From that, is everybody all right without doing anything else? Combining these two, we could say that the domain is all real numbers. And the range, well, that turning point, that y value of 1 is the smallest, and we'll be working up from there. The axis is always a vertical line through the vertex. So the axis is going to be that line, x equals negative 3. And you notice how much information we've got, a good idea of what our graph looks like, the domain, the range, the direction, from doing nothing else but looking at the equation. For my intercepts, this time I'm going to do it in reverse order for a minute. For the x-intercepts, we said we'd let y equal 0, which gives me 0 equals x plus 3 quantity squared plus 1. I'll subtract 1 from both sides to get -1 is equal to x plus 3 quantity squared. Then when I take the square root of both sides, I get x plus 3 is equal to 2 plus or minus I, which is not real. I can't graph that. So we're going to say we have no x-intercept. But now I want to backtrack for a minute and look at what we know. This point is a minimum. We're opening upwards. Just going on that information that we're going upward from that 1, wouldn't that tell us that we're not going to be crossing that x-axis? So for the y-intercept, if we substitute x equals 0, f of 0 would be 0 plus 3 squared plus 1, which would be 10. And so I'm going to cross the y-axis. I'm sorry. Yes, the y-axis up here at 10. I'll go the other side of my line of symmetry to get another point, and those should be enough to graph this one. When you use the graphing tool for a parabola in my labs, you'll click on that parabola button. You'll put your cursor down on the vertex, and then when you hit another point, that's all that you will need in my labs to sketch that parabola. So, for an equation that looks that involved, do you see how looking at it is what we're doing is we're taking our basic parabola, x squared, we're moving it left 3, up 1, and sketching it, and how those rules for transformations can give us this vertex form, which is pretty simple to graph. Next class, we'll look at the end of the unit, which is graphing the ones that aren't in that vertex form. Is everybody all right if we stop here today? Any questions? Is there anybody who came in after I took attendance that needs me to add them? Jed, I think you came in late, yes?
Yeah.
Anybody?
I did too.
Stephen, thank you.
Have yourself a good day.
You too. Have a good, remember, no class on Wednesday. It's Veterans Day. Have a good Veterans Day. And remember to take that quiz before Thursday night. And remember that I don't care if you did it in my labs. If I don't see work in Blackboard, that grade's not going to count.
All righty.
Have a
Thank
good-
you.
Bye-bye.